Hey guys, welcome back to another video. So here it's been a long time since I've done another paper, but here we are. Today we're going to do the January 2018 paper 3H for Maths A. And as usual, you can use a calculator, and this is of course the higher tier. So without further ado, let's jump straight in, guys. Oh yeah, and just as noise, you must always have your ruler in centimeters and millimeters, a protractor, a compass, pen, pencil, eraser, and calculator. You don't necessarily need tracing paper, but why not? And yeah, the formulas. You're always given Pythagoras' theorem, but it's of course good to know it. Some trigonometry formulas here. The general cone surface area equation with uses of Pythagoras here, so where L squared equals h squared plus r squared, so you can relate these two actually. You also got the spheres equation, triangle equations, and a bunch of others, so definitely take your time to check them out. Alright, so anyways, here we go. Okay, question 1, guys. So Pascal has a map with a scale of 1 unit to 125,000 units. His house is 14 kilometers from an airport. Okay, so before I read part A, just to make a quick clear reference here. So when something is written in units, what it really means is that for every 1 unit you have 125,000 units. Or for every 1 centimeter, as it's usually measured, we have 125,000 centimeters. Now notice how they're talking about kilometers here. They're saying in real life, the house is 40 kilometers from the airport. That means the right hand side should be measured in kilometers. So the first thing you guys want to do is quickly switch the units on the right side to kilometers. And to do that, because we work in centimeters, you should first go to meters by dividing 100, and then go to kilometers by dividing 1000. And doing all this in your calculator, you should get 1.25 kilometers. So remember, just a quick reference, just do this in the calculator. So choose the original number, divide it by 100 to get the answer in meters, and then using that answer, so yeah, just to make it clear, you get this. Then using 1250 meters, divide this by 1000, and this will give us 1.25 kilometers. Okay, so now we're good to go. Now what's it saying? His house is 14 kilometers from an airport. So work out the distance on Pascal's map, so the left hand side, in centimeters from his house to the airport. Now, the easy way to do this is because we're going from kilometers to centimeters, we can just use this scale factor. That means for every centimeter we get 1.25 kilometers, or what we could do is just say 14 divided by 1.25 will give us the exact answer. So go ahead and put down your calculator, guys. So let's see what we get. And this gives us 11.2 centimeters. And it makes sense because it has to be smaller than the original. Now, let's move on to the next one. Okay, so Luciana has a map with a scale of 1 to n. Her house is 4.8 kilometers from the station, so that's the right side. On Luciana's map, the distance from her house to the station is 19.2 centimeters. Oh, so it looks quite the same. Work out the value n. So let's go ahead and smash this as a ratio, guys. So we can say on the map, is 19.2 centimeters from the station compared to 4.8 kilometers in real life. And now to bring this down to 1, all you gotta do is divide it by itself. So dividing both sides by 19.2, if you do that, this should straight away go down to 1 centimeter. And dividing this by 19.2, well, we have to check that on the calculator. So check this on the calculator, guys. So for these kind of questions, when you want to find a single unit, depending what side it is, because it's on the left side, you got to divide both sides by whatever's on the left. So 19.2 divided by 19.2 is clearly 1. And then repeat on the right. If it was on the right side, you go divide it both by 4.8. So let's see what this gives us. So 4.8 divided by 19.2, and I got 0.25. So the value of n is 0.25 kilometers. So or a quarter, both is fine. Okay, next question. So 2a, use your calculator to work out the value of this figure here. Write down all the figures in your calculator display. Alright, so this is dead easy. So literally just, if you got a Casio calculator, straightforward. Straight away use the square root button, followed by the fraction button, and then go ahead and plug all the values in. If you're using a regular calculator, well, always do the top half first, divided by second half, and then square root that answer. So let's see what we get here. So have a go. So I don't know. I'm kind of surprised that they give us questions like this, But see what you get. 0.29 square root answer. And okay, so on my calculator it says 2.2587800006. I'm not sure how many digits you need, but just put everything you see, yeah? Actually, you can still get this wrong, so just be very careful. Now, using your answer to part A, correct this to two significant figures. Well, all this means is that you just need the first two non-zero digits, and then round up the third one. So because it's 5 or bigger, 2.2 ends up becoming 2.3 to two significant figures. Easy, really. So let's go. And here we are. So question 3. So it says A equals P squared plus 7Q, and it wants us to work out the value A when P is negative 7 and Q is 5. Easy. If you got a calculator, this is a joke. So all you do is literally plug in this value and find A. So we can say that A equals P is negative 7 squared plus 7 and Q is 5. You could do this mentally if you like, or just smash in a calculator. And if you do that, you should get, so let me just do it. So minus 7 squared, which is 49, plus 7 times 5. And I got 84. Okay, correct me if I'm wrong, but I think that's what you should get. So next one, A equals, so same equation. Work out the value of Q when A is 100, so replace it with this with A with 100, and P is 11. So let's go ahead and do this. So copying this equation, replacing A with 100 equals P squared, so 11 squared, plus 7Q. Now we just got to rearrange it. So the first thing you want to do is just, do the math quickly. So subtract 11 squared across. So you can say 100 take away 11 squared in your calculator. That should give us, hold up, let me just check this out. Squared, you should get minus 21, so you get minus 21 here equals 7Q. And then all you do is divide 7 across. So you can say Q equals minus 21 over 7. And that is simplified to negative 3. Easy, guys. Moving on. Okay, so number 4. So Stefan has a biased 5-sided spinner. He spins the spinner 80 times. Okay, so keep note of that. His score each time is the number that the spinner lands on. And the table shows information about his scores. So basically, the 5 here represents how many times it landed on 1. 12 means it landed 12 times the number 2, and so on. So find the median score. So the median literally means the middle number. So if he done it 80 times, the mid time he did it was a 40th time. So this is halfway between. So we got to find the 40th event. So let's count it up. So first things first, he did 5 over here. The first 5 were number 1, so you can say 1 to 5, he landed at 1. And then the next 12, so we can say from 6 to 17, because 5 plus 12 is 17, he got 2. And then adding 16 more, he did 16 more, so 17 adds 16 should give us 33. So from 18 to 33, he got 3. Now from the 34th, okay, I don't even need to do maths, but adding 32 to 33 will give us 65. That means the 34th to the 65th spin, he got number 4. So what's the median score? That means the median score must be 4, because the 40th one lies between this range. That's it. That's what you do. You just find the range of it. Okay, so next one, work out Stefan's mean score. All right, so here comes a little bit more maths. So the way this works, all you have to really do is find out the so-called fx. Fx is known as the frequency times the actual spin, the number you landed on. So for example, when you do that, you're going to sum it up and then divide it by the total frequency, which must be 80. So let's have a go. What do we have? So first things first, fx means this number spin, which is x, will be 1 times 5, which is 5. Next one will be 2 times 12 is 24. 3 times 16 is 48. Yep, checking that. 4 times 32, so 64, 128. And last one, 5 times 15 is 75. Check if you guys got these answers, and now add all this up and then let's divide it to find the mean. So we're going to have 5 plus plus 48, 128, and 75. So I got 280. That means the mean must be the total fx, which is 280, over the number of times it was spun, which was 80 times. And now, just put it on your calculator, you should get 3.5, and that is the mean, guys. So that means, just looking at it on a broad sense, 3.5 is somewhere between 3 and 4, which kind of makes sense because that's where most of the frequency landed. So the answer had to be between 3 and 4. That's where the bulk of the population was. Okay, and move on to the last bit. Okay, here we go. So Stefan's going to spin the spinner once more. Okay, Stefan, let's see. So use the information in the table to find the estimate for the probability that the spinner will land on an even number. Okay, so even number then. What does this mean? This means we just look at a table and we just have to observe when it lands on an even number, which is, in this case, 2 and 4. Straightforward. And then just knowing the frequency, we know that if it lands on a 2, it's going to be 12 out of 80 chance. If it's going to land on 4, it's got a 32 out of 80 chance. That's it. That's all you do. So probability of landing on an even means we're going to have practically 12 plus 32 out of 80 chance. Out of 80 chance. And that should give us 12 plus 32, so that's 44 over 80. And I don't think you need to simplify really. You could if you want. In just case you have to, you should get, well, you can leave it a decimal. You can leave it as this or just put in a calculator and you should get 0.55. Any of these answers work. Now let's move on. Algebra, yes, I love this question. So for question 5a, solve the equation 3 times 1 minus 2y equals 2y minus 7. Okay, there's beautiful tricks here. So first things first, what we want to do, we want to expand the left side. So do 3 times the left-hand side. So 3 times 1 minus 2y. This should give us 3 minus 6y. Now we just copy the right side. Now all I do here is I look at the numbers, minus 6y plus 2y. I don't like negative numbers, so I want to add 6y across both equations. So this cancels out and this raises to an 8. So we should be left with 3 equals 8y minus 7. And now I want to add 7 because I don't like negative numbers. That goes and this raises up to a 10. So we've got 8y equals 10. And lastly, dividing by 8, you should get y equals 10 over a. Simplifying this, you should get 5 over 4. Voila, that's it. Now, part B. Oh, another easy one. So write down inequalities shown on number line. So all you have to know, we just pop in an x. Let's just call this x, for example, yeah? This tells you that the range of numbers x can be. So you can see x can clearly be any number between -3 and 4, right? So that's kind of cool. So we can just say this. X can be between -3 and 4. However, when something is shaded, this actually means it includes 4. So that means it can also equal 4. When it's not shaded, it means it excludes 3. So it has to be just bigger than -3. And that's it. Now, solve this inequality. Again, easy stuff. So what I do, just treat this inequality as an equal sign, okay? And just do your thing. So now what do? So solving this linear equation, first thing you want to do is just subtract 13 to make 2m the subject. So we've got 2m greater or equal than, and you calculate 8 take away 13 is -5. And just divide by 2. So m is greater or equal than minus 502. Easy stuff. Okay, 6. So work out the length of QR. Easy. So these kind of questions always labeled as x, just to give it a name, yeah? And now, if you can see clearly, this is actually in the perfect form of Pythagoras' theorem. How do we know? Firstly, we have a right angle triangle, which is true. And then Pythagoras tells us that the side of this one, so let's call this one a squared plus b squared must equal the hypotenuse c squared. So we can just say this. And we know oops equals c squared. And we know this is c squared because it's the long diagonal hypotenuse side opposite the right angle. Let's do this. So we can say 5.9 squared plus x squared. 5.9 squared plus x squared must equal to 10.6 squared. And then just doing the maths, so we can say x squared equals 10.6 squared minus 5.9 squared. So let's put this side on the calculator and then square root for your final answer. So 10.6 squared minus 5.9 squared should give us 77.55. And then square rooting that answer, you should get x equals, how many three same figures? 8.806, and rounding up, 81. Okay, so always round up carefully. You don't want three numbers, so give them three numbers. Okay. Okay, part B. So now we need to work out the size of angle PRQ and then give your answer to 1dp. So angle PRQ, let's check it out. So what would it be? So the way I look at it is I start at P, and let me change that actually to the blue pen. Start at P, go to Q, no, go to R, then go to Q. That's what it said, PRQ, right? Yep, so that means it's always the angle between, so PRQ, so it must be here. Let's call this one, I don't know, Y, yeah? Now, what do we have here? So with this angle, all we need to do really is find the value of it. And to do this, we need to use SOHCAHTOA. Why? Because this is a right angle triangle, and SOHCAHTOA works with right angle triangles that involve angles. Okay, so first things first, what do we have here? So if we look at this carefully, when we have a length opposite angle, we call this one the opposite, so O. And we can just pick which one we want. And when we have the hypotenuse, we call it the H, hypotenuse. So now looking at the equation here, which one can we use? Well, actually we can use everything, but in this case we need the one that revolves around O and H. And then that is clearly so. So that means our equation must be S, so the S part is sine. Sine cos tan. In this case we're going to have sine Y, sine of the angle equals O over H. So it'll be O 5.9 over 10.6. 10.6. And that's it, guys. Now to find Y, you just have to inverse sine this value. And to do that, let's do it now. So inverse sine of 5.9 over 10.6. You should get a nice 33.8 degrees. And that's it. Where's the answer? 33.8 degrees. You know, so far this paper's been really easy, hasn't it, guys? I mean, I'm kind of glad. Except the question one could be a little off balancing. Everything's been quite okay. All right, let's check it out. So the length of a line is 12.4 centimeters. So this is not related. Correct to one decimal place. Take note of that. Write down the upper bound of the line. So when we look at the line 12.4, we need to think how it rounded to 12.4. So the only way that was possible, if 12.4 was rounded up from 12.35 or rounded down from 12.45. And that's it. So this will give us the upper and lower bounds. You think about it, to 1 dp, just below this one you get 12.4. 1 dp just above this one you get 12.4. And now we want the upper bound, which is clearly the upper value, so it's 12.45. Easy. Okay, number 7. Ooh, 7 looks cool. So on the grid, draw the graph of y equals 5 minus 3x for the values of x from minus 2 and 3. Easy. I got a very easy way to do this. You're going to love it. All you have to do is plug in the smallest value. Because it's a linear equation, we know it's linear because it's just x and y. We can plug in one value for x and one value for y and then just draw a straight line between them. So let's do it. So you can say when x is negative 2, what do we get? Well, plug it in. You're going to get y equals 5 minus 3 times negative 2. Smash this in your calculator. You're going to get 5 plus 6, which is 11. So the first coordinate is going to be minus 2 and 11. Now when x equals 3, so pick another one. So pick the endpoint 3. When x is 3, repeat the same method. You got y equals 5 minus 3 times 3. What does it give us? Well, 5 take away 3 times 3, which is 9. In your calculator, should give us a negative 4. So our next coordinate is 3 and 4. And that's it. Now plug both of these in. So it's not going to be very near my one. So let me zoom out a bit actually. Okay, so minus 2, 11. Where is that? So you go on the line and you just go to negative 2 and then jump up to 11. So it should be there. So let me put a nice cross. More there, yeah. Next one's 3, 4. So go 3 and then 4 up. There. And then just draw a nice, beautiful line. Yeah, I mean, I'm gonna fail this epically. So, God, oh God, how can you be so bent? And then, yeah, but in this case, make sure you use a ruler, guys. Yeah, don't do like I did, but use a ruler. Unfortunately, my app doesn't actually have a ruler here, so. But bottom line is, it needs to be a perfectly straight line linking these 2 points and then just extend it across. Using a ruler. Key point. Okay, question 8. So unfortunately, I can't actually do this question, but let's have a read. So use a ruler and compass to only construct the bisector of angle ABC. So this part in the middle. You must show all your construction lines. So first things first, what is the bisector of this angle? What this means that you need to split this angle exactly in half using your compass and ruler. And to do it, we need to calculate firstly the angle of the total here using your compass. Find the midpoint and just plot it over here like a nice X. And at this point, draw a perfectly equal line splitting them up. So you must have an equal angle here and an equal angle here of the same quantity. Now, I've got this demonstration here which I'm using from one of my references. Let me just switch it across. So according to this one, it says that an angle bisector splits a given angle exactly in half, as you can see. So suppose this was line A, point B, and C. Here is the perfectly half amount. What you do is that you put the compass at this point and then just twist it around. So just put some marking, okay? And at the same point, use the compass again. Put your point here and then do another marking, this time through the center. Also put your compass over here and then do another marking. So you should bisect or intersect at this point. Then you just get a ruler and just draw a nice straight line and then say the values of both angles here. And say that this has been perfectly bisected. Yeah, so that's really it. I mean, apologies I can't show it by demonstration because I don't have the tools, but again, just make it clear. You stick your compass here and then you twist it so it should cut somewhere like here. And then you twist it again and it should cut somewhere here as well. And then using your new compass, let me change the color to purple. You start here and then you bisect it downwards so it should cut here somewhere. Do the same here and it should cut like here. And then you just draw a straight line. Easy. So we can call this one step A and step B. All right, hopefully this demonstration sort of helped. Otherwise, let's move on. Right, so question 9. The diagram shows 3 sides, A, B, B, C, and C, D. So here we go, and we got angles. So it looks like we got total angle of a straight line of some sided polygon. The size of each interior angle of the polygon is 4x plus 28. The size of each exterior angle is x minus 13. Work out size of n. So before we jump into these interior angle equations, first things first, we need to just observe that this straight line, interior plus exterior, let me write here, must equal the sum of them to 180 degrees. So let's write down. The sum of these two angles must be 180. So we have 4x plus 28 plus x minus 13 must equal 180. Let's do the quick maths. So we got 4x plus x is 5x. 28 take away 13 is, quick maths, 15. Must be 180. Then what you could do is subtract 15 across, so you should get 165. And then divide this by 5. I think I know the answer, but I don't want to make a mistake. It's 33. This tells us instantly that the value x is 33, so we can find the value of the interior angle. So, okay, so that part is done. So why is this useful? So what does this mean by the interior? If x is 33, that means the interior should be 4 times 33 plus 28, which is 160 degrees. That means the exterior here must be 20 degrees. Now, let's go ahead and use all the formulas we know about interior exterior. So we should know firstly that the sum of all interior angles must be n minus 2 times 180. Okay? We can also use the fact that the exterior angles are equal to 360 divided by the number size. And you know what? This is perfect because we can rewrite this equation as the number size equals 360 over the exterior angles. And we know the exterior value is 20, so that means the number size must be 360 over 20. And using this in the calculator, you should get exactly 18. So the number size is 18. Okay, oh, I love these questions too. So number 10, we've got straight line L is parallel to the line with this equation here, 2y plus 8x equals 5. Cool. We know that this L passes through the point with these corners, and now they want us to find an equation. So first things first, if something is parallel, what does it mean? This means that we must have the same gradient. Okay, so this means that this new equation, this new line L, has the same valued gradient as this one. Now the question, where is this equation in the typical y equals mx plus c form? And remember guys, this is the form you want all the time to realize that the gradient is always the value after x when it's written like that. So let's rewrite this equation as this. So what you could do firstly is subtract 8x across, so we're going to have 2y equals minus 8x plus 5, and then divided by 2, so we're going to have y equals minus 4x plus, and divide this by 2, 2.5. Now this, my friends, is actually the standard y equals mx plus 3 equation with a gradient of -4. This means that the line L, let's talk about line L, will have the same equation of y equals mx plus c, but instead of m, we're going to have -4 again, but a new c because it's just the same parallel line. Except this hits at, let's say, 5, and this hits somewhere else, we don't know where. Could be above, we don't know. That's what we're here to find out. Now, what else do we know about this line? We know that this line passes through the point of these coordinates, 2, 3. This means when x is 2 and y is 3, we can plug it here and find a value of c. So let's write that down. We can say at 2, 3, this becomes 3 equals minus 4 times 2 plus c. And then solving this becomes -8. Plus it across, we're going to have 3 plus 8. This means c would equal 11. Hence, our final equation is going to be, so replacing c with 11, our final equation is going to be y equals minus 4x plus 11. Okay, number 11. Just looking at this head on, you can see this is straight up a compound depreciation question. But let's check it out. So on the 1st of January 2016, Celine buys a laptop for $330. I love that name, just like the Batman girl, Catwoman. The value of the laptop decreases by 23% each year. Okay? Work out the value of the laptop in 3 years, basically, from this point in 2019. Give your answer correct to the nearest dollar. So, here is a beautiful formula I'm going to introduce you guys. This is known as how to relate these, even for these kind of equations. For this one, you could always say that the original value times 1 plus or minus some rate, so this is the multiply, to the number of years must give you the new value. Okay, this is the flat out best equation I've got. So all we have to do is replace everything here and smash in the calculator. So what do we know? So firstly, we know that she buys a laptop in 2016 for $330. So that means the original value was $330. And we know that it decreases by 23%. So we go take the negative. So it'll be 1 minus 23%. And we know this happens for 3 years because we need to work out the value on the 3rd year. And that's it. Put this in the calculator and you should get the answer. So let's have a go. So you can write 330 times 1 minus 23% to the power of 3. And this should give us 150 point, you should round this up, $66. Okay, oops, where's dollars? ARS. That's it. Very easy, very easy. Easy 3 marks, honestly. Okay, question 12. Solve this algebraic fraction. Alright, so the first rule of this kind of question is always clear out the fractions. Okay, so whatever numbers you have, just multiply across. So first thing I want to do to clear out 3 is to multiply 3 across. By doing that, this 3 cancels out, and then now we multiply the top by 3 because it's different, and this by 3. So we should get x plus 4 plus, because it's not 3, you got to multiply top half, so it'll be 6x plus 9 over 4 equals, and multiply 7 by 3, you get 21. Now the next thing you want to do is to clear out the bottom, so multiply it by 4. So because if you multiply by 4, this cancels out, and now you multiply the rest. So this side becomes 4x plus 16, the left side. You leave the original now, it reduces to 6x plus 9. And multiplying 21 by 4, you should get 84. Okay. Just having a little breather. Now, this part, what do? So now we just tidy up. So you go 4x plus 6x will give us a 10x. 16 plus 9 is good old 25. And 84 is 84. Doing the quick maths, that means 10x must be 84. Take away 25. Oops, I should do this mentally. 84 take away 25. 59. Just making sure I'm doing it right. And x must divided by 10, and x must be 5.9 or 59 over 10. Okay, question 13. So the number of people live in Tokyo is 3.57 times 10 to the power 7. Ooh. So times 10 to the power 7. What this means, this is actually 10 million. So there's actually, oh my god, there's a lot of people. So there's 3.57 times 10 million people in Tokyo. That's a lot. Now, write this figure as an ordinary number. Well, to do it, all you have to realize that 10 to the power 7 really means take 7 numbers. There should be 7 digits after 3. So because we got 3 and we got 5, 7, that's 2 digits already. We need 5 more. 1, 2, 3, 4, 5. So 5 zeros. That means this is practically 35 million. So there's 35,700,000 people in Tokyo. Easy stuff. So it's 7 digits after 3. Yep. So the land area of Tokyo is 1.35 times 10 to the power 4 square kilometers. Work out the mean number of people per square kilometer live in Tokyo. So all you have to do is literally find the number of people per, means divide by the rate. So it's going to be exactly what you see. So it'll be the number of people, which is 3.57 times 10 to the power 7 divided by the per square kilometer, which is 1.35 times 10 to the power 4. And that's it. Now all you do is really 2 ways. First, you can smash this in a calculator, and hopefully your calculator should give a standard form. Otherwise, what you could do is just do 3.57 divided by 1.35. Do that in your calculator. 7 divided by 1.35, and you should get 2.6444 recurring times, and then you just do 10 to the power 7 divided by 10 to the power 4. And to do that, you just subtract the powers because they're both 10. So you get 10 to the power 3. That's it. And then give your answer in standard form to 2 single figures. So this means the first 2 non-zero digits. So 2.6 times 10 to the power 3 per square meter. Okay. Number 14. So 15 students were asked how many countries they had visited, and here is a list of their results. So you get a string of 1, 2s, 3s, and quite a few of them, up to 15. Find the interquartile range of the number of countries visited. Well, interquartile range means the range between the quartiles, literally as it says. So it means between the third quartile, the upper quartile, minus the lower quartile. How do you do this? So because there was 15 students in total, we need to find the midpoint. So we need to find the midpoint between 15. So you could look at 7.5 or the 8th person. So that's how it works. The idea is to use this formula. You just to find the lower quartile, it just means the first quarter of the number of people you have, 15. And just to make the error clear, we say 15 plus 1, so 16. This means the 4th person. And to find the third quartile, we just do the third quarter of 15 plus 1, so 16th person. So this will give us the 12th. Now we just circle them. So the 4th person was here, and the 12th person should have been there. And this part would be in the middle person, just if you want to balance it out. And the range is going to be the upper minus the lower, so 11 take away 3. And that's it. Simple as that, guys. Literally, that's all you do. So the answer is 8. Okay, question 15, guys. So what do we have here? Ooh, so we have some good old circle geometry now. Let's check it out. So we've got A, B, and C are points on the circle, center O. Cool. DA and DC are tangents, so this is useful. Because we have tangents, DA and DC, this means that this is straight off the bat 90 degrees, yeah? Because that's the thing about tangents. Tangents to the circle where the center is, always 90 degrees, so make sure you memorize that. Okay, always perpendicular, so 90 degrees. What else do we know? And here we want to find the angle of ABC, so over here, ABC, ABC. Now, a few things to know. Notice that this is in the position of a spaceship. So the way I memorize this is that the angle here, bang in the center when it's open like this, is always twice the angle at the circumference. So that's the rule. The angle of the center here, 2x, is always double this angle here. So whatever this is 2 times bigger. Now, to me, I think we have everything we need. All we do is find the value 2x and it's divided by 2 to find this angle, and we're done. And we know straight away that this shape here is a quadrilateral because we have a four-sided shape, meaning it must sum up to 360. So let's do the maths. So we could say that this shape here, AODC, the one over here, must add up to 360. So we could say 76 plus 90 plus 90 plus 2x must be 360. Let's do it. So 76 plus 1990, which is 180, plus 2x must be 360. Subtracting 180 and subtracting 76. So let's have a look. Take away 180, take away 76. You should get 2x must be 104 degrees. So that's this angle here. The angle in the center is 104, meaning here is half of it. So x must be 52 degrees. Done. 3 marks to that, easy. Okay, use algebra to show that the recurring decimal is given as this. Easy as well. So all you have to really do is just know something. The very first step you do is to always say let x equal that number they stay. So 0.3, and then just let 4, 5 recur constantly. So it'll be 4, 5, 4, 5, 4, 5 indefinitely. Now the trick is to multiply this by powers of 10 as a series of tens until you get the same number of digits after the decimal. The same digits in the same position, basically. So let's just have a go. Firstly, let's multiply by 10 here. So we're going to get 10x. If you multiply this by 10, so decimal should move here. So it'll be 3.454545 and so on. Now, if you multiply by 10 again, what happens? You're going to get 100x. This will give us 34.545454 and so on. Now, there's a problem. The problem is that if you look at the decimal number here, this begins with 4.5 and this is a 5.4, so it's not in the same place. What we want is that we want a series where we get the same digits like this across, preferably. So whatever the number in front, at least the decimals can be like that. So when we subtract them, all of these cancel out. So what we could do is times by another 10, so we get 1000x equals, and now we're going to get 345.454545. And yes, there we have it. Now we can see clearly we have what we want, the 454545 and 454545. So let's say this. So what we could do, we could say, let's use the 10x equation and 1000x equation, and let's subtract them. So we could say 1000x take away 10x will give us 990x, and then 345 point the recurring plus minus the other one, all the recurring decimals will disappear. So we left with 345 take away 3. So let me just cross these out. And 345 take away 3 will give us 342. Voila, we're practically done. I mean, this is actually a nice way to prove recurring decimals. Now all you got to do is literally divide by 990 to find the value x. And then all you do now is just simplify this in the calculator. And when you do it, smash in the calculator, it will give you 19/55. And that's it. Done. Okay, number 17. So, more algebra. You know, I really love these kind of questions. We go manipulate, move about. I mean, it kind of makes maths more fun. So, what do? Here they want us to make the subject from this kind of funky looking equation. Now, the trick is just take it step by step and get rid of the square root and then clear the fraction. That's the aim, yeah? So first things first, how to get rid of the square root? Well, to do it, we need to square both sides. So this entire equation, it becomes x squared equals everything inside, 2b minus a over 7 minus am. The next thing we want to do is to really get rid of this 7 minus am as a fraction and put it as a whole number. So multiplying this across, you should get x squared times 7 minus am equals 2b minus a. Cool. Now let's go ahead and expand this side. So let me just change the pen color for a second. So expanding this, what do we get? We should get 7x squared minus, and I like to write alphabetically, amx squared. And this would equal 2b minus a. Right. Now, this is the part where you need to be very careful. So the trick is, to make a the subject, we need to put all the a-related terms on one side. So just to make it clear, the a-related terms are here and here. So we need to smash these together and the rest away. So what I will do, I will plus a across here and I'll subtract 7x squared to the other side. So what we're going to have is a minus amx squared equals 2b, and then subtract 7x squared minus 7x squared. Cool. And now the beautiful thing is to really isolate them, you can factorize a out. So we can say a bracket 1 minus mx squared, because if you take a in both, you're left with 1 and you're left with mx squared. And then we're done. Just copy the rest. Now the easiest step is just to smash this underneath, is to divide it across. So we can say therefore a equals the right hand side divided by the bit in the bracket, 1 minus mx squared. And that's it, we are done. And you get 4 marks of that. So hopefully I didn't butcher the step, but I think overall it should look a bit like this. Let me know what you guys got, and leave a comment, because it's something worth discussing. So let's move on though. Okay, question 18, guys. I love this question too. So what do you have here? So we've got mathematically similar flasks A and B. Okay, so this means that B must be proportional to A. That's what similar means, yeah? So flask A has a height of 7 and B has an unknown height. So let's call this height, let's just call it H, yeah? Just keep it simple. Okay? Whereas A has a surface area of 132 and B has a surface area of 297. So the question clearly probably wants us to find the height of flask B. Now the cool thing about this question is that you can just say that firstly, the heights are directly proportional and the areas are, proportional in terms of area. So we could say, in this case, 7 is directly proportional to the height, and 132 is an area proportional to 297. What this means in terms of maths, you could say that, for example, h over 7 must equal some factor k, and the surface areas 297 over 132 must equal k squared. That's where k is the scale factor, yeah? So all we want to do is find the value of k from the second equation, plug into the first to find height. So let's do it. So using the second equation, you can just literally square root this one. So you can say k equals square root of 297 over 132. And then plug it here, and you can say therefore height equals 7 times k, which is 297 over 132. And that's it. Let's put it on the calculator, yeah? So you got 7 times the square root of 297 divided by 132. And I got 10.5. So actually the height is not bad. It's 10.5 centimeters for B. Okay. Let's put it here. Now what else do we know? We know that the volume of flask B is 567. So again, volume just works like area. Instead of k squared, it will be k cubed. So for B, so let's call the volume A. So we can say that the relationship between the volumes of B and A must be the same as k cubed. But we already know some of these values. We know what k is and we know what VB is, the volume of B. It's 567. So we can say 567 over the volume of A must be equal to k, which was root 297's square root of that. 297 over 132 all cubed. Now all you do is rearrange it and just say volume of A equals 567 divided by all of that. So that means the volume of A equals 567 divided by all of K. 297 132 cubed. Oh man, so easy stuff. Just use these relationships. And just to make it clear for the area ones, it was the area, okay, the surface area of B over surface area of A must be k squared. And the left one, the linear one, can be the height of A over the height of B over the height of A equals k. You could do upside down, but they must all be consistent, yeah? Right. Yeah, so let's go ahead and finish that question. So 567 divided by, oh, how am I going to make this work? So it'll be the square root of, hold on, this is kind of tricky. Yep, so square root of 297 divided by 132 to power 3. And then 567 divided by answer. So I got 168 centimeter cube. So let me know if you guys got the same result. I believe this is correct, but double check it, yeah? Double check it. And let me just check it. So it'll be 168 times power 3. Yep. So just to make it clear, if you solved k earlier, you should have got 1.5, yeah? Just to simplify it. And that's it. That's done. Okay, number 19, histograms. Okay, I love histograms. So the table gives information about the distance in kilometers by traveled by 120 people to get to an airport. Okay, so you're given some range between 0 to 10, 10, 25, and so on with a given frequency. The only thing we don't have is frequency density. So before you finish this off, we need to find the height, frequency density, okay? So we can actually draw this in. Now, the way I look at this for frequency density, I just think of it as like an area of a rectangle. So drawing a nice little diagram, and I really recommend this, guys. Always do something like this, FD on this side, class width here, and just draw a rectangle. The area inside here, we call this the frequency. So you can imagine, you can think of it as class width times FD must give you the frequency. So you can say class width times the frequency and density will give us the frequency inside. So, and now in order to find frequency density, if you rearrange this, you can just say that the FD equals frequency over class width. That's it. And also, just to make an extra note, we can say the class width for each of this one is a difference. So from 0 to 10, the class width is 10. From here is 15, 20, and 15 again. Okay, 15. Now let's do the maths. So frequency density is going to be, in this case, frequency over class width. So it's going to be 33 over 10, which is 3.3. 39 divided by 15 is 2.6. 36 divided by 20 should be 1.8. And 12 divided by 15 should be 0.8. And this represents the height, yeah? So just like a triangle, like a rectangle, height and base. Class width is the base, frequency density is the height. Now let's plot in. So between 0 to 10, there must be a height of 3.3. So let's just check the scale. We want to fit this in. So making like every line 1, so if this was 1, 2, 3, and 4, you could fit them all in. So 1 with a height of 3.3 and a width of 10. So it should be up to here. So then just draw it neatly with a ruler, yeah? So this would be what you need. So this would be the first one. Oh yeah, it's always good to write the frequency inside. So I'll do that in a different color. The second one will have will be between 10 and 25. So 25 is here and has a height of 2.6. So 25 mark is here, and then 2.6 is it here? 2.6 is there, yeah. So I mean, this is the best I can do here. So try and make it neat in your versions. Okay. Next one would be height of 1.8 and goes up to 45. So 45 is around here. 1.8 is just before the top, so about here. Oh gosh. Oops. And then down. Okay, and lastly, going up to 60 has a height of 0.8. So 0.8 is here, but then 60 is there, so crosses around there. That's it. As long as you made this neat and you do it carefully, you should be fine. That's it, and just fill out the frequency. So you got 33 here, 39 people here, 36 people here, and just 12. That's it. This should be a perfect histogram. So one of these people is to be selected at random. Find an estimate for the probability that this person traveled more than 30 kilometers to get to the airport. So just to make it clear, we have 120 people. So the probability will be over 120. So who traveled more than 30? So it will be the people after here. You know, it will be these group of people. So all you have to do really is just work out the area of what you have. So let me just delete this 36 seconds so don't confuse. So we just go find the area of this block and add it to the area of this block, 12. So the area of this block will be between 30 to 15, so it has a width of 15 and a height of, we said 1.8, yeah? So you just do 15 times 1.8, should give us an area of 27, so there's 27 people at this point plus 12 here. So that means the probability of being more than 30 would be 27 plus 12 over how many people? 120. And that's it. And this should give us 39 over 120. Should give us 0.325. Whew, question 20, guys. Oh man, I'm getting a bit tired here. I hope you're all doing well out there. So what do we do here? So it looks like we've got surds involved. So it tells us that the square root of 50 plus root 128 minus root 200 can be written as n root 2, where n is an integer. And here they want us to find a value here. So the trick is to actually simplify these roots or reduce them as small as possible till you get something root 2, and then see what you get. And that should give us our n. So let's start with root 50. Let's break it to pieces. So for root 50, what do we have? So root 50 can be firstly written as this. It can be written as the square root of 2 times square root 25, because 2 times 25 is 50. Thankfully, the square root of 25 is just a whole 5. That means we're done here. Our final result will be 5 times root 2, which is 5 root 2. That's good. Now let's move on to root 128. What do we have here? Doing the same idea, divide by 2, so you get root 2 and root 64, that makes 128. And again, realize that root 64 is just a whole 8. So same thing applies, this is 8 root 2. Now finally, root 200, which I think we can actually see what this is. This gives us a root 2 and root 100, and the square of 100 we know is 10. So that means here we have 10 root 2. Not bad. Now we just do some simple maths. So now it tells us that we have root 50 plus the second term minus the third term. So we're going to have 5 root 2 plus 8 root 2 minus 10 root 2. So 5 plus 8 is 13. 13 take away 10 is 3. So the answer is 3 root 2, or n is 3. Easy. Now, let's have a look at the next one. So given that a is a prime number, okay, so a is specific here. Simplify the following. Right, and give your answer into this rationalized form. So what this means is that the surd here in the bottom fraction has clearly been removed. Okay, so the only way to remove it is to rationalize the denominator, and to do that we need to times up and down by the same amount, so by 10 root a and 10 root a, and that will actually give a whole number at the bottom. So let's do it. So if we're going to multiply the top half by 10 root a, we're going to have 5 root a times 10 root a should give us a 50, and then 2 root a will give us a whole a. That's how it works. Now a times this will give us 10a root a. Easy. And now doing 10 root a times 10 root a, 10 times 10 is 100. Root a and root a gives you a whole a. Alright, now tidying all of this up, oh, this is actually easy. Tidying this up, you can just split this up. So we can do 50a over 100a plus 10a root a over 100a. So you can, the cool thing about fractions is that you can always partition to 2 bits like this all the time. But the thing is, both of the top numbers, top terms must have everything from the bottom. Thankfully, just 100a. Now what can we do here? So this is an easy fraction. So 50a over 100a. So a's cancel out, and 50 over 100 is a half. Same thing applies. So 10a over 100a, a's cancel out, and 10 over 100 is a tenth. And then we're left with root a. And finally, what does it say? X and y are fractions. So that's it. So x is a half and y is a tenth. Okay, a very interesting looking question, number 21. So here they want us to factorize these terms. Ooh. Take a moment to have a look at this one. So this is weird because actually the first idea, in order to factorize this one, we have to think of it as 2 ways. I mean, there's 2 ways to approach it. I can think of this as a difference of 2 squares, like, let's have a look, as x squared minus y squared, which will give us x plus y and x minus y. In this case, the whole term inside is the x and the whole term inside is the y. If we copied it like this, if we let 10a minus b equal x and y equal 2a minus 5b and plug into here, we should get a result. So using the difference of 2 square method, so the dots method, we should get the following. So the first bracket, it will be 10a minus b will be the x bit, plus the y bit, which is 2a minus 5b. Okay, that's the first one. Now the second bracket will be the same thing, 10a minus b, but it will be a negative sign. And then y would be, again, 2a. Oh yeah, this is a b, by the way. So it would be 2a minus 5b. Because you got minus sign, it would be minus 5b. Okay? Now, oh yeah, always put the brackets round. It always helps, yeah, or else you might end up messing up the answer. Like I almost did, actually. So now all you have to do is expand the bracket and tidy up. So we're going to have 10a plus 2a, which is a 12a here, minus b plus minus 5b should give us a negative 6b. Same thing, so 10a take away 2a will give us a 8a, minus b minus minus 5b, so minus b plus 5b will give us plus 4b. Alright, what's next here? Can we do anything else? Yeah, I mean, looking at this one, we can factorize 6 out of this bracket. So we're going to have 6 times 2a minus b. And here we can factorize 4 out. So we're going to have 4 times 2a plus b. Ooh, it's actually, it's almost done. And then we can just stick them together. So we got 6 times 4. So when you got stuff like this, you can actually multiply numbers. So 6 times 4 is 24. And we're left with 2a minus b, 2a plus b. Now, I'm not sure this is a complete factorize, or the final solution will be to reverse it back to a difference of 2 squares. This can also be rewritten as 24 times 2a all squared minus b squared, just like the difference 2 squared format. So it's actually 24 4a squared minus b squared. So I think one of these two answers will give you full marks, since they both give you the same result. So I can't quote me, but for this one, can we discuss this one in the comments? I want you guys to discuss this one and see what results you both came up with. Because there's no solutions at this time of writing, well there is, but it's not available. Check what result you got and let me know. Thanks. Okay, question 22. So this one's an interesting one. So when a biased coin, so in other words, the head and tails are not the same, is thrown 5 times, the property of getting heads, 5 heads, is 32 over 3,125. But I said that horribly. So work out the property of getting 4 heads and 1 tail when the coin is thrown 5 times. So first things first, let's analyze this. So you got a biased coin, it's thrown 5 times and you get 5 heads in a row with this probability. So this means property of getting heads, 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 and heads must be 32 over 3,125. So one thing to know about a coin, so if it's head, it must have a certain probability and it must be fixed, and the tails will be the whatever the value of heads, so it'll be 1 minus the probability of heads, yeah? Okay, so let's try and work this out. How do you know what the probability of head is for a single head? Well, what we could say firstly is that the only way to get the head is that each of this must have the exact same probability to get 32 over that. And if you can see, 32 can be obtained by 2 to the power 5. I can just see that now, but how do we know that? The only way to do this is to realize what one head would be. And we know that a single head, oops, where's my pen? A single head can be obtained if we find the 5th root of this probability, because remember, they're all identical and they're all multiplied continuously, so it's the same power. It's like x times x times x times x will give us this, y times y times y times y will give us that. So let's work it out. Let's find the 5th root of this in our calculator. So when you do that, this is what I get. But I'm using a rubbish calculator. I get 2 over, and then the bottom number, the 5th root of 3,125, 5. So I got 2/5 basically when I did that. If the probability of head is 2/5, that means the probability of tails must be 3/5. Alright, so that's the probability of tails. Now the question is, work a probability getting 4 heads and 1 tail. Now it's easy. So we're going to find head, 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 and then a tails. And to do that, it's going to be 2/5 times 2/5 all the way across times tails, which is 3/5. So we know the bottom is 3,125. Now, what is this one? So it'll just be 2 times 2 times 2 times 2, 16. 2, 4, 8, 16, and then 16 times 3 would be 48. So this is your answer. So even though it's a biased coin, Heads has a lower chance, and yet it's been heads all the time. Okay, that's it. That's literally how you do it. When you have repeated things, find the nth root. In this case, 5 repeat heads, find the 5th root. Easy. Let's go. Okay, 23 now. So what do we have? So we're given a function fx as a fraction 3x over x minus 2 with a domain saying x can't be 2 because you can't divide by 0, so x can never be 2. And that g is a function such as gx equals 4x over 5. Now, find the value of g at the point when f is minus 4. Okay, so that's what it means. So this literally tells us find the function of g when the value of f is at negative 4. So we got to find what this value is first to plug into g. So what is f negative 4? Well, plug in, so it'll be 3 times minus 4 over minus 4 minus 2. And this should give us minus 12 over minus 6, which is just a whole 2. So we want to find the value at g2. All of this is 2. And when g is 2, it will be 8 over 5. So 8/5. Cool. Express the composite function fg in the form fgx. And then simplify this fraction. So the same thing applies, but instead we're starting with the fraction with the function f, and we're going to smash g inside it. So there's always g inside f. So this this entire function is going to go inside fx. So if fx is 3x over x minus 2, we're going to replace all the x's with whatever gx is. And that's it. So that means we've got 3 times 4x over 5. So we're going to have 3 times 4x over 5 over, and then this x becomes, again, 4x over 5 minus 2. Whew. Now, you're probably thinking, how the hell do I do this? Well, it's not so bad. I'm telling you now, it's not so bad. Let's just have a look why. So the trick is let's just tie this out. The trick is to firstly multiply everything by whatever the fraction tells us to on both sides. Notice that they both have a 5. So the trick is to multiply up and down by 5. Okay? And what happens? When you do that, this cancels out, so you're going to have 12x, and then the 5 cancels out, so you're left with just 12x, because the 5 and 5 cancels out. And here, if you multiply this by 5, this 5 cancels out, you're left with 4x. Times it by 5, you get a 10. See? Not so bad. Not so bad. Just find the common thing to multiply, which is literally get rid of the fraction. And now what you do next, you just simplify. So you can see they're all even numbers, so divided by 2, you should get 6x over 2x minus 5. And I think that's it, really. I don't think you can do any more. I mean, this is my best result. If you guys got something better, please discuss it below. Okay? Thanks. Now, express the inverse function. So the inverse, what do we do here? Inverse of fx. So let's write fx down again. So 3x over x minus 2. I'm going to call this y, yeah? Y equals 3x over x minus 2. I'll copy it right, yep. Now the inverse is easy. The trick of the inverse is to really flip the letters around. It's to literally invert. Okay, invert the letters. What I mean by this is that all the y's become x's and all the x's become y. So our equation, which was originally this one, looks a bit like now this. So it'll be x equals 3y over y minus 2. And this is easy. Now all you have to do is literally make y the subject. And then when you make y subject, you have a function of x, and that would be its inverse. Done. Easy. Boom. So step 1. Let's clear the fractions. Let's smash y minus 2 across. So we're going to have x times y minus 2 equals 3y. Expand the bracket. You're going to have xy minus 2x equals 3y. And now the trick is, like one of the early questions, is to isolate the y's. Keep all the y terms together. So what I'm going to do, I'm going to subtract 3y and plus 2x across. So then I have my y terms on one side and my non-y terms on the other side. And then finally, what you want to do here is factorize the y out. So you're going to have x minus 3 equals 2x. And lastly, divide x minus 3 across. So you have 2x over x minus 3. Boom. Okay, vectors now. Question 24. So vectors is actually very easy once you see the trick. So what do we have? So we've got OABC is a parallelogram, and we're given two vectors. From O to A, we call it 4A, and from O to C, we call it 3C. So what do we know about everything else? Oh yeah, so because we know this, we can actually highlight a few points here. Every time you're going in the same direction, the vectors of the same direction of the same size will be identical. So we can say OC is identical to the direction of AB, which is also 3C. Remember, same size, same direction. And OA will be the same as C to B, which is 4A. Easy. Now, what else do we know? So it says the point X over here is such that CBX is a straight line such that the ratio C to B is 2 parts to B to X, which is 3 parts. Meaning if 4 to A represented 2 parts, that means if you found 3 parts, divide by 2 and times by 3, you can see that it's going to be 6A, because 2A is obviously 1 part. So that means this must be 6A. Okay, this is exactly 3 halves bigger than this one, or 1.5 times bigger. Okay, that's cool. Now find in terms of A and C. Oh yeah, the point Y is such that the vector CY, C to Y, is equals 2 times AX. Okay, so if we had to do a line A to X, which isn't too bad, it's just going to be 3C plus 6A. CY will be half of that, yeah? So CY equals twice the length of 8x. So wherever AX is, which is obviously 3C plus 6A, this means CY must be equal to double this one, which is 6C plus 6 plus 12A. Oops, hold on. I'm trying to use a rubber here. 12A. Yeah, just trying to get this narrowed down. So wherever CY is, I don't know, but it seems to be, because it's written in the same way, it's going to, of course, be parallel, but just longer. We don't know where, but it's longer. Okay, so find in terms of AC the vector OY. Okay, so we got to find where this Y value is. Okay, you can just say C to Y. We could say Y is probably, I don't know, up here somewhere, yeah? Find O to Y. So the only way to get to O to Y is that we need to get from O to C first and then C to Y. So that's actually quite easy. O to Y is going to be going from O to C first, plus, and then you go from C to Y. And O to C is obviously 3C, and C to Y we already have. So the total will be 3C plus our CY, which will be 9C plus 12A. And here we are, guys, question 25. So let's go ahead and wrap this up, yeah? So what do we have here? So here we're given a pyramid with a horizontal base A, B, C, D, E, which is actually a regular pentagon. This regular pentagon has a center O and every single length is 8 centimeters. We can also see that at the top of the pyramid is P, which is vertically above O. We also know that M is the midpoint between between C and D, and that OP, the vertical height, is exactly 10 centimeters. Now here comes the tricky part. Is we need to calculate the size of angle from APM. Ooh, correct to 1 dp. So how shall we approach this? Well, let's make a target here of what we need to do. So to find APM, I mean, the way I see this, we're given this length, so it looks like we're going to be dealing with some right angle triangles, okay? So let's do this. So we can say to get from A to P to M, we could evaluate this knowing the fact that we have a straight line here, and we can work out the right angles between each of these points, A and M. Okay, so we can call this angle alpha and this angle beta, yeah? So when we're working with AP and center O, triangle AOP, we can work out alpha using trigonometry and OPM using trigonometry again to find beta. And then adding these two up will give us the angle for APM. Okay, so that's the target. The angle APM is going to be alpha plus beta, wherever they are. Now, let's do this. How should we approach this? So the first thing to observe here is the fact that we have a midpoint, M. This means that the lengths banging between CM and DM must both be 4 centimeters each. Okay, so I'm going to go ahead and resketch this, yeah, at the bottom. So let's suppose we got lengths ED across here, yeah? So what was that? EDC, yeah? E, D, and C. And we can see that O is in the center, and we got M is the midpoint here. Okay. One thing you want to know about regular pentagons that we need to know is interior angles. We should know that the sum of the interior angles of a pentagon using a formula n minus 2 times 180 or 3 times 180 will give us 540 degrees. This means that each interior angle divided by 5 will give us 108 degrees. So everything here is like 108 degrees and so on. And because we need to approach the center O, we can say straight away that going from A to O must be, at least for these points, it will be 54 degrees here and 54 degrees here. From AEO, EAO and OAB. Okay? Okay, so that's just an idea. So let's go ahead and sketch this now. So first thing you want to do is realize that if the interior angle is 108 degrees, that means if you slice in the middle to reach O, this must be 54 degrees. And because M is in the center of D and C, if you cut it directly, this would be a right angle. Okay, perfect. That's all we need to know. So we got triangle ODM. Now, what can we do with this? So the cool thing about this is that we can use this to evaluate some kind of triangle here. So let's say this goes vertically up to P and this is 10 centimeters. And let's just keep it there. So firstly, what can we do with OM? And this is length 4. OM can be found using SOHCAHTOA. So let's take OPM over here. ODM. God, so many letters. This is 54. This is right angle and this is length 4. Let's find the value OM. So OM can be found using trigonometry, and this is the same as 4 sine 54. I'm going to do this quick. I'm going to assume that your trigonometry knowledge is there, SOHCAHTOA is there. Knowing this, we can therefore construct a right angle which involves M, O, and P. Okay, so this is the north line. Yeah, let's go straight to P. And here's the center circle O, and here's the midpoint M. We said OM was exactly 4 sine 54, and OP must be 10. And this is right angled, by the way, because when you're vertically above, it's always right angled. Now, using SOHCAHTOA, we want to find the value of the angle OPM. So in other words, our beta here, yeah? Where is it? Beta? Yep, our beta here. So what do we do? So here we can see that we need to use TOA. So it's going to be tan beta equals 4 sine 54, whatever that is, over 10. And then finding the tan inverse of this in the calculator, we should get 17.9319. Okay, so that's one octile. So we found one angle. Now we need to find triangle AOP. So we need to go back to basics, yeah? So for triangle AOP, we could just look at it like this. So we can pull out, let's say, I don't know, AOB for a second, yeah? Let's pull out AOB. Let me change the color pen to red. AO, and let's say this is B. So one thing we need to know that from A to B, we know that the length of a regular pentagon is 8 centimeters. So this must be 8. And if you're going to go from A to O, this angle, the interior angle is sliced in half, just like it was at D. So it'll be 54 degrees. And it's the same for B. This is also sliced in half to 54 degrees. Now, what you want to obtain at the end of this is an angle of this length. You want to find pretty much the length of AO. And when you find the length of AO, we can construct another right angle triangle from AO and goes vertically up to P. So hopefully you guys are understanding my explanation. So this would be AO, so A to O, and then we can get straight to P. And we know this is right angle. So when we find AO, and we already know this is 10, we can also find the alpha here, and then we are done. Okay, so AO, let's think for a second. So here we can use the sine rule. And oh yeah, we can actually work out this angle here. We got 54 and 54, which is 108. Subtract from 180, this will give us 72 degrees. Right, let's find AO as I was saying. So using the sine rule, we can say that this length, AO, over the sine of 54 must be equal to any length, let's say AB, which is 8, over its opposite, sine 72. And if you solve it, if you put this in the calculator, 8 over sine 72, and multiply sine 54 across, this means that the length AO should give us, double check if I'm right, 6.805 centimeters-ish. Right, so that can go over here. Now finally, So yeah, now we can use SOHCAHTOA. So we can use tan to find the angle here. We can say tan alpha equals the opposite, which is the new value AO over 10. So let's do that. So we can say tan alpha equals 6.805 over 10. And then cos and tan inversing it should give us an alpha of, let me see, 34.236 degrees. Whoa. So yeah, so I think that's really it, isn't it? And now to find the angle APH, we just sum these up. So let me do the next page. So we can say for this triangle APM, this is alpha plus beta. So we can say angle APM equals, let's put it in. So in your calculator, write 34.236 plus 17.9319. Smash in the calculator and round it to 1 dp, you should get, well, I got actually 52.2 degrees. Oh, and that's it, guys. I mean, I hope this is right. Again, this is based on no solution. This is just based on some practice. And, you know, wasn't so easy, but it was definitely doable. It's all 5 marks. And if you guys got this, then give yourself a pat on the back. But for this question, as the previous ones, I would like us to discuss, yeah? We should try and discuss this and see what we all get, because it's good to compare and have a finalized result so everyone can see this clearly. But anyway, thank you so much for watching, guys, and you know, I hope we can do more videos like this. But other than that, catch me. You should be able to see more videos on my next recordings. But anyway, guys, I mean, I'm just beat. I mean, this is over an hour long, hour and a half, I don't know. So yeah, I'll catch you guys next time and have a great day. Ciao.